Infrastructure as code is not just a faster way to build cloud resources. It is a faster way to change security controls. A route table, identity role, firewall rule, storage setting, or logging configuration can move from safe to risky through a code commit. SecurityX thinking starts with this. If code changes controls, then code review, policy checks, drift detection, and ownership become security controls too. Terraform style desired state describes what should exist. Security adds why it should exist that way. A secure blueprint says which network paths are allowed, which identities can act, which data needs encryption, what logs must be enabled, and who owns the control. Without intent, a clean apply can still deploy a weak design perfectly. The plan step is a security moment because it shows intended change before it becomes production reality. Senior teams do not treat plan output as noise. They ask what security-relevant controls are being added, removed, or modified. A risky change should stop before apply, not after monitoring discovers damage. Policy as code is how you make guardrails repeatable. A pipeline can check whether storage is public, encryption is enabled, identity permissions are scoped, and logging is on before the change reaches production. The goal is not to block every change. The goal is to make unacceptable risk fail consistently and explainably. Control drift happens when reality no longer matches the approved blueprint. Someone changes a security group in a console. A hotfix disables logging. A temporary exception becomes permanent. The risk is not only that configuration changed. The risk is that your evidence, threat model, and assumptions are now wrong. Ansible is often used differently than Terraform. Terraform declares and provisions desired infrastructure state. Ansible is commonly used to configure systems and remediate known conditions. For security, the important question is not which tool is better. It is whether the remediation lane is authorized, tested, logged, and scoped. So automation fixes drift without creating a second source of chaos. Imagine a payment platform team manages cloud networking and storage with Terraform, then uses Ansible to harden Linux images and validate logging. During an incident review, security finds that a storage bucket was made public for troubleshooting. One logging agent was disabled, and an identity role gained wildcard permissions. The senior engineer does not only ask who clicked the button. They ask, what control should have prevented the change? What sensor should have detected drift? What remediation is safe? And who owns the exception decision? Use a simple framework. First, know which controls the code can change. Second, put policy checks before apply. Third, detect drift continuously or on a defined schedule. Fourth, remediate through approved automation, not ad hoc console changes. Fifth, record evidence and control ownership. That loop turns infrastructure automation into security assurance. Knowledge check. A cloud team uses Terraform for network and storage resources. An engineer makes a manual console change to open a storage bucket during troubleshooting, then forgets to reverse it. Which control most directly addresses the gap? The best answer is drift detection with an approved remediation process and control owner. Code review matters, but it did not see the manual change. Encryption matters, but it does not prove the bucket matches approved state. More documentation helps, but a sensor and remediation lane close the can come back. Recap. Infrastructure as code is powerful because it makes infrastructure repeatable. Security depends on making the right controls repeatable. Treat desired state as control intent. Review plan before apply. Enforce policy as code. Watch for drift. Use remediation automation carefully. And keep evidence tied to a named control owner. That is how Terraform, Ansible, and drift management become part of SecurityX level engineering judgment.